This is the LinkBot. It's an educational robot that's modular. So you're able to use these snap connectors to attach wheels, to attach robots to each other. And they're a little bit larger, more manageable, so you're not having to dig them out of the carpet. We have something that's called Bump Connect, where you take modules and you connect them wirelessly over a Zigbee-compatible channel. So I'm going to press the pair button on one to make it the controller, and the pair button on the other to make it controlled second. You bump them together, and you're able to run through some of our pre-programmed modes, like tilt drive. The accelerometer of one robot is controlling the motors of the other. There's also something that's called, that we call copycat mode, where when you rotate the hub of one, the other rotate. And if I were to stop this wheel, you're able to feel the force feedback in the controlling LinkBot. So in this way, you're able to get kids engaged in driving robots around, as you can see on my next slide. So once you get kids engaged, once you get them entering the matrix and shrinking. So once you get kids engaged with robots and get it moving and getting dynamic, then you can start feeding them math and computer programming. But there's still a big gap between being able to create with robots, and that is the coding aspect. So we've bridged that gap with something we call pose teaching. And there's buttons on the outside of the robot. Now you can push the record button here in my hands and move the robot around. Now I'm pushing record, and then once I've generated a motion that I want to play back, I push play, and it runs through those poses, kind of like stop motion animation for robotics. So what's more is we can take a USB cable, plug it into the micro USB on the outside of the robot, and our software converts those poses into C++, Python, and we're working on Java. So there's a video, thank you. There's a video that I'll show you of pose teaching a gripper robot. I'm pushing record on the top of the robot, and on the left-hand side, you see the poses being generated, and on the right-hand side, code is being dynamically generated. Every time you push record, you can see it showing up in Python. There's a drop-down menu on the right-hand side that changes it from Python to C++, and you're able to start with that as a base to start coding. If you want the angle to be a little bit greater, or you want it to slow down, kids can make changes to the values of that code, push play, and our software interprets a code and executes it immediately. So it's a very dynamic way of creating with robots.
The kids have all the fun.
So how do you tie that in with math and the Common Core? We're partnered with the University of California, Davis to develop math curriculum with a focus on C++. There's competitions where kids drive around on a course. There's also artistic expressions like a music video competition where kids will program the robots, they'll pose teach them, and the robots are now actors in a play. They'll cut it together, add music, and that's the competition. There's also different types of stories that you can tell with robots. So it's not just our accessories that come in the box. We want to make it open to all sorts of different creative outlets. Like we have just a standard bolt pattern on the outside, like number 6 screws you get from the hardware store. And you're able to add cardboard, laser cut materials, 3D printers. All of our parts are available on our website to download. You can 3D print them and also upload your own designs. So there's something, this is what we call the LinkBot lock popper. You're able to, it goes through and brute force tries every possible combination for a padlock, and the front face rotates the padlock, and the top face pops the lock. And once the lock releases, then our encoders are able to tell that change, and it'll display the number on the screen. The code is open source. It's on our website, as well as the 3D models for the parts that you can 3D print. And yeah, I think everybody has one of these in their everything drawer that they forgot the combination a long time ago. So this is a solar panel array. We have breakout boards that allow you to sense voltage. It'll track the sun across the sky, and it'll use that voltage to charge itself. So it's able to run indefinitely. So there's different breakout boards. For example, this is a robot that we paired up with SmartThings, and you can water your plants from your cell phone. It also has a moisture sensor, so if it gets dry, it'll water it. And there's a sensor in the cap that'll tell when the water's out, and it'll alert you. This robot actually changes your blinds. So let's say it gets a little dark in your house. This will open the blinds, let the light in. So automation, creativity, there's a lot of different applications and fun things that you can do with the LinkBot and our open source hardware accessories. This is kind of the big go. This is in fast motion, but this robot is not connected to a computer. I am dynamically post-teaching it. I've fast-forwarded at the beginning, but once you push play, the robot runs through the poses, and you can have a humanoid walking robot in under 5 minutes. So you plug in with a USB into any one of the LinkBots. The LinkBots communicate wirelessly, and you're able to download that code, make changes to it, and create more complex behaviors. So the thing that we learned was that it's critical to get the robot moving and get kids engaged immediately. And what we need is working capital. We have over 800 robots in high schools and middle schools, and I think it could be in a lot more if we get the price down. Partnerships, and thank you very much.
Okay. Yeah, you didn't mention price. Stay up here for question and answer.
Yeah, excuse me. The LinkBot is $179 retail, but we're selling to schools for $135 each.
Per piece or?
Per LinkBot, and that comes with a few accessories.
Really expensive.
Yeah. But it also, I think that if you take into account the fact that it has the battery built in, it's a lithium-ion battery, 5 hours runtime that can actually be used effectively in the classroom, and you don't have all these batteries and battery chargers that are clogging up the wall space.
How do you get the price down to $10?
I need you for that. I need your help.
You go to China, right?
Not even China. I mean, I'm wondering if there are a bunch of people working on battery technologies. Yeah. We should get to the Singularity University and get our people working with you on it.
That'd be lovely.
This is amazing. Blown away.
By the way, we have a couple of additions to the panel. Obviously, Vivek, who's a teacher, researcher, and journalist. Robert Scoble, who is also a journalist working at Rackspace and has been shooting videos of entrepreneurs for over a decade. And Joe is with the Unified School District, Soledad, and you're the Director of Technology. So what did you think, Joe?
I think it's great. I think one of the trouble that we had with our robotics teams is they're so expensive. And so you need so much sponsorship just to get kids access to it. This is a easier way to get it, especially down to the lower levels of elementary. And one thing across the state is the GATE programs have been severely cut, but hopefully this technology like this can easily bring it back up.
What were you spending to set up a robot team?
I don't even, at my previous district, it was very expensive. You had to have major sponsors. And they had great events. They had like a basketball hoop event, I think was their last one for the first robotics team. But I would say 20,000 just to build a robot, if not more.
So we have a pack that of 25 LinkBots that can go into the classroom with accessories and curriculum for $5,500.
$5,000 for 25 robots.
25 robots.
So that could teach your whole class, and the assumption would be maybe 20 different classes could come in there once a week or something and use the same bots.
Yeah, and this robot isn't just for competitions. It's also useful as an example of mathematics and different principles in the classroom.
Was this on Kickstarter or it's never?
Yeah, we just successfully finished a Kickstarter. We raised $45,000 last week.
Wow. And you can pull up the Kickstarter page, Kickstarter, LinkBots. Congratulations on that. So what was the goal of the?
40.
So you just made it.
Yeah, it was very dramatic.
Very cool. More questions? Yeah.
How much did it cost? How much capital has been invested in you to get to this point?
So we've received 2 National Science Foundation grants, a Phase 1 and Phase 2 SBIR, and we just got the Kickstarter, which we haven't gotten paid for yet, but we're privately
How
owned.
much total?
So it would be $650,000
So less than $1 million gets you to this point. Congratulations.
and a lot of sweat.
Yeah.
Yeah.
Have you guys thought about selling it direct to consumer? Like, Christmas season is coming up.
So approaching the consumer market requires a lot of capital. We're focusing on partnerships with curriculum developers as well as the centers that want to get robots into kids' hands to get them excited about STEM.
You should go to Dean Kamen and see if you can partner up with him.
Have his phone number?
Yeah.
Yeah, I think so. Somebody has his phone number.
Dean Kamen, of course, is the person who made the Segway
Segway,
and
also Slingshot, which will
exoskeleton.
solve the world's water problem, and a bunch of other great. He's the Edison of today.
First
And
robotics.
he also launched First Robotics. He would be excited about this.
Can you talk about the positioning a little bit more? There's a lot of robots out there, Lego, Arduino, Raspberry
Is this
Pi.
microphone up? Yeah. Ask a question.
Sorry, not. And what age group are you going after? I know you partner with UC Davis, but you talked about generating C++ code. What age are you developing curriculum for?
Well, we have curriculum for middle school and high school, and we have a large resource of functions that really simplify the code so that we have middle schoolers currently coding in C++ today, and they're doing some amazing things. We're positioned so that it's a little more manageable in the classroom period. Not just, I think robots are relegated to an after-school thing,
Yeah.
and we want it to be an effective teaching tool during the day.
Why not JavaScript instead of these harder languages?
We're working on JavaScript. That's actually coming next.
Or Go. Google's Go. Zoho is switching to Go, for instance, and they said it's even more elegant than JavaScript.
All of our functions, our libraries are in C++, so it's very easy for us to jump.
One of the countries that's furthest ahead in bringing technology to the masses is Uruguay. They did the 1 laptop per child, and then now they're looking at bringing robotics to children as well. I'll connect you with the president's office. They would be very interested in this.
How much investment do you need to make it, let's say, $1,000 for the same kit? Because that requires maybe miniaturization, maybe redesigning it, maybe rethinking the packaging, rethinking electronics, that kind of thing. Is that $5 million or $10 million? What does it take?
I believe that would be closer to $5 million.
To get these robots down to $1,000 for a set of 25 for a classroom, you think would cost $5 million to get there?
Yep. Roughly. I think that's a very, very complex question.
Yeah.
But yeah, I think that's appropriate.
Time helps too, because we're seeing a whole lot of trend lines going in your direction, right? Sensors are getting cheaper, processors are getting cheaper, classic and 3D printing is getting cheaper, on and on, right?
Yeah.
But to accelerate that, instead of just waiting the 5 years, it's going to take to get that price down. To accelerate to 2 years is going to cost money.
Yeah, there's an opportunity to be had in order to get these robots into kids' hands in the next few years. And I'm looking for support and help in order to make that a possibility.
I can see the classroom impact of this. I'm not so sure that the Best Buy customer would understand this or want it.
Yeah.
Is there a way to make it? Are you thinking of making your business like have a consumer arm and really think about how to make this a consumer product that you would buy at Apple Store or Best Buy store?
I'm not looking to Best Buy, but I do think that the make movement is huge. So all of our breakout boards are Arduino. We're going to have open source breakout boards that people can design their own and be part of, and interfaces about any type of sensor too. So we're trying to interface with that. That's sort of a bridge into the consumer market where parents can buy it as a fun kit over the weekend for their kids.
Great. Let's hear it for LinkBot. Well done.